Like a screen door on a submarine, you don't want ports that are a little too open. On the other hand, you don't want to be a house with no doors or windows, right? A vault that no one can get into. If you're a switch, you need to have ports and interfaces, but it can be confusing when you're working with a Catalyst 3850 or 3650 and you've got your physical ports and your virtual ports and your management ports and your console ports. Let's make sure we know what all these ports are. So first, the console port. You remember this guy. This is going to be what's used for a device to be able to connect with, let's say, a DB9 connector to an RJ45 in the back, or with a USB mini Type B connector in the front. And then they're going to have access to what? That gives them access to the CLI, all right? Direct terminal CLI access. If it's been configured, I could take my device and I could connect it directly into the management port. Now I can use HTTP-based access or Telnet or Secure Shell if those are available. It's a network port that we're working with, and it's using the special management port IP address. Hopefully DHCP has been set up to hand out IP addresses, or I will have to statically configure my client to work within the same range. Then I can open up the web interface. So this is out-of-band management, kind of unexpected. Maybe my device is not functioning like I was hoping it would, and so I need to jump in and manage it. Okay, then we get down here to, of course, our switch ports. Now, those are the classic switch ports and the uplink ports that are designed for a particular purpose. So our switch ports are gigabit. Our uplink ports are 10 gigabit. Those uplink ports are designed with a very specific purpose in mind. They are designed to give me uplink access, probably link aggregation to the distribution layer, all right, of our switched environment. All right, going from access layer, that's what a 3650 or 3850 is, to the distribution layer. Our switch ports, on the other hand, are designed to connect to, of course, end devices, our clients and our servers and our printers, right, whatever I need out there. And also, don't forget, it is through the switch ports that we will then be providing converged access to our access points, right? Our access point supporting clients, right, that are enjoying their radio communication out here are going to end their CAPWAP tunnel here because it's a converged switch, but they got to get there through an access port. Remember that access ports are going to have VLANs assigned to them. They're going to have a VLAN ID assigned here. Uplink ports are almost definitely going to be defined as trunk ports over on that side. Those VLANs are going to be used to isolate the traffic, create separate broadcast domains. They're going to have separate subnets associated with different VLANs, right? We know all of that. Remember that as a switch that can provide routing functionality, that I will also have VLAN interfaces. So a VLAN interface provides an endpoint so that the traffic coming from a VLAN can reach this device and then route out to another VLAN. We're going to have VLANs to support both the access points, that's what we call management VLAN, and then we're also going to have client VLANs that are associated with the end user devices that are wired and the wireless clients that are going through these CAPWAP tunnels. We'll need to have virtual interfaces for web-based authentication, the splash pages, for example, that the clients see, the management for the access points, as we said. We're going to have our port configuration and our VLAN configuration. All of those are necessary in order to do our job. Okay, so this is kind of the big picture of what we see when we're talking about our switch ports interfaces, and we're going to have to do some mapping between the VLAN world and the physical interface world in order to get our job done.